This video is related to the 1.6 extension in the Big Ideas Math 6. And so I'm going to start off with something that you just need to be aware of, that there are such things as mixed numbers and improper fractions. And mixed numbers and improper fractions are all fractions that are greater than 1. And so the idea is a mixed number has a part that's a whole number and a part that's a fraction. That's why they call it mixed, because it's a combination of two things. And then notice if I take this whole square and I break it up into fourths, I can see that I have 1 square plus 3/4. But the idea is I can take this mixed number and I can also write it as an improper fraction by counting how many fourths I now see altogether. And 1 3/4 is the same as writing 7/4. This is a mixed number, this is improper. They mean the same thing, and if you drew a picture, it should look very similar. And so now if you have an improper fraction and you can see the numerator is bigger than the denominator, this also is a fraction that's bigger than 1. And what I could do is I can understand that this fraction bar means to divide. So if I put 4 on the outside and 10 on the inside, 4 goes into 10 twice, and I have a remainder of 4. So I could say 2 2/4 is equivalent to 10/4. Sometimes it's easier to understand fractions when you change improper into mixed numbers. So let's go on to the warm-up to just have you practice converting mixed numbers into improper and improper into mixed numbers. So if I draw a picture of what 3 3/4 looks like, I might do this. 1, 2, I'm drawing rectangles because I like them better than circles. And then if I highlight 3 of those rectangles, I'm showing 1, 2, 3, and then I need to highlight 3/4. So before I can highlight 3/4, I actually have to cut this rectangle up into fourths, right? And so now I've got 3 3/4. And then if you realize what I'm going to be doing to change this number into an improper fraction is I'm looking at the size of the pieces that are in this fraction part, and they're fourths. That means I need to convert everything else into fourths. So I would have to take this and cut that into fourths. Every single whole bar would need to be cut into fourths. And then if I count them all, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus the 3 that I had before. So it turns out what I'm doing is I'm taking my whole number 3 and I'm multiplying it by 4. And then I'm adding in the extra 3. So I get 3 times 4 equals 12. Plus the 3 over here gives me a total of 15/4. Right? I'm not really doing anything with that number except I'm trying to figure out if I want to change this fraction into how many fourths I have. I first have to cut up the 3 whole rectangles into fourths. That's why it's 3 times 4. That's what I'm going to do here without drawing a picture. I'm going to do 4 times 5 is 20, plus 4 is equivalent to 24/5. Now when we go in the other direction, I've already told you that the fraction bar means to divide. So you go 3 into 7 and it goes twice and I have 1 left over. And so it becomes 1 2/3. I take the remainder of my fraction and I write it over the divisor. Now I'm going to show you a picture of what this looks like. If I've got 7 candy bars that I'm trying to divide between 3 people, so far I don't have much room to I'm counting 1, 2, 3, 4, 5, 6. Okay, so here's my 7 candy bars. Let's say I'm dividing this evenly between 3 people, right? That's what this means, 7 divided by 3. So person A gets 1 candy bar. Person B gets 1 candy bar. Person C gets 1 candy bar. Now I go back because I still have 3 whole numbers. 3 whole candy bars. A gets a candy bar, and then B, and then C. Now I've got 1 left over that I need to split between these 3 people. So it makes sense first to break it up into thirds, and then I can write in a little a and a b and a c. So guess what? I'm going to highlight this, and it's going to match the answer to my division problem, because A gets 2 whole candy bars plus a third. That's what we figured out here when we divided. I took the one that was left over and I divided it up into thirds because that's what makes sense, because I'm trying to split it between 3 people. So 7/3 is the same thing as 2 1/3. Now I'm going to do the same thing, but I'm not going to draw a picture because I'd have to draw 11 things divided by 4. This is going to be a little more abstract, but I take 11, I divide by 4. I get to, when I subtract, I have 3 left over, but the 3 left over has to be split or divided between 4 people or in 4 ways. So my mixed number is 2 3/4. So that's just a little review on the difference between improper and mixed numbers and how you go back and forth. So now let's get into the lesson where the essential question is, what must be true about the size of pieces when adding or subtracting fractions? And what must be true is this. This is what you're writing in your notes. When adding or subtracting fractions, the denominators have to be the same. But to make them the same, you have to find the least common multiple of the denominators. And now I'm telling you that the least common multiple is the same thing as the least common denominator. Hey, you know how to find a least common multiple. You either make a list, right? So we did the list method or we did the ladder method. Those are the 2 ways that we have to figure out the least common multiple. And it turns out that that is going to be the same thing as the least common denominator. Okay, let's look at an example. So here's what I want you to write in your math notebook. Example 1, you're adding 5/8 plus 1/6. Now, if you have a picture, sometimes it can be helpful. Here's what I'm going to show you. If you say that Mr. Santana ate 5/8 of a large pizza and Mrs. Latusek ate 1/6, and how much did they eat altogether, right? How much of the whole pizza? Now, I'm not asking you how many slices because that would be too easy. It would be he ate 5, she ate 1, they ate 6 altogether. But that's not what I'm asking. I'm asking you what fraction of the pizza did they eat. So I'm going to go ahead and highlight Mr. Santana's. He ate 5/8, and notice this circle has been cut up into 8 because I'm trying to represent 5/8. So I highlight 5 out of those 8, and I'm going to write 5/8 at the bottom. Okay, now Mrs. Latusek's pizza is cut up into 6. And I'm highlighting the 1/6 because that's what it says she ate. So there we go. Hers is 1/6. Now here's the cool part. Once you figure out the least common denominator, what you're doing is you're trying to figure out, I need to cut this into smaller pieces, but I need them to be equal to the smaller pieces in this pizza. And the way you do that is you look at the multiples, right? And so the multiples of 6 are 6, 12, 18, 24, 30. I'll just do the first few ones. And then 8 is 8, 16, 24, 32. And so what you're going to notice is it's easy to cut 6 into 24ths because you have to split them into 4 more sections. And you cut 8 into 24ths by adding 3. So I'm just going to show you that when I go 1, 2, 3, now I've got 4 smaller slices. And so, oops, I need to go back and do the highlighting again. So I'm going to go back to just my 1/6 and my 5/8, and I'm going to tell you that the least common multiple is 24. So if I take this little wheel that now has 24 pieces in it, and if I slide it over on the pizza that represents Mr. Santana's, I can count how many 24ths you see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, it turns out that what I'm going to be doing is I'm going to be multiplying by some number to create an equivalent fraction over 24 because the least common denominator is 24. And with Miss Latusek's pizza, if I move this over, I can see that her pizza is equivalent to 1, 2, 3, 4 24ths. But if I didn't know that because I didn't have a picture, what I'm trying to do is I'm trying to create equivalent fractions, but with the same denominator. So I already told you that on the 8s, if you cut each 8th pizza into 3 more pieces, it's 8 times 3, which is 24. And then I would also do 5 times 3 because the highlighted pieces were 5. And so I'm cutting those into thirds and I get 15 24ths. Now the 1/6 pizza, I had to cut that into fourths, so I multiply by 4, and there's only one piece that's highlighted, and I have to multiply that one by 4. So I get 15/24 is equivalent to 5/8, and 4/24 is equivalent to 1/6. And now I can actually write these vertically the way I would normally add, but I want to remember that the numerator counts how many, and the denominator tells you the size. So right now, I know the denominator has to be 24, and now I'm just adding the 15 plus the 4 to get 19/24 of a pizza. Now, it seems like that's a lot of steps, and it is. But once you keep practicing and you start understanding how to create equivalent fractions with similar, alike denominators, we call them common denominators, then your life will be much easier when you start getting into fractions that are bigger or maybe a little more complicated. Okay, that's the first example. So what I want you to do is I want you to pause this video and I want you to try these questions on your own. 2 1/6 plus 3 4/9. So you can see that the 1/6 has been, that this circle has been cut into 6. So this represents 2 whole, well, it's actually representing yards of ribbon. So this stands for 2 1/6. And then over here, we have 3 4/9. So I'm going to color in all of the 3 whole circles because that represents the 3 in the whole number. And then I would color in 4 of the 9s. 1, 2, 3, 4. Okay, so remember that what you're looking to do is you're looking at the denominators. Oops, let me go back to red. You're trying to find a common denominator with 6 and 9. So I have 6 and I have 9. So you could just start making a list, right? I'm assuming you paused and now you're watching. You tried this on your own and now you're watching me solve it. So I make a list of my multiples of 6. 6, 12, 18, 24, 30. And then my multiples of 9 are 9, 18, 27. Ooh, wait, I could stop already because I see a common multiple of 18. That means with these 6, I would need to, so this is times 1, this is times 2, this is 6 times 3. So what I would do is I would take all of my 6 that were here and I would cut them into thirds. By putting 2 slices, I now have 3 pieces. And then with the 9th, this is, oops, times 1, this is times 2. So for this one, it's a little bit easier. I would just cut each of these pieces that are already there in half. So the idea is now I'm creating the same size pieces and they all are going to be 18. And I'm just going to delete that. And I was going to delete the other, oh, let me just erase that. And then I'll drag the pieces over and show you what it looks like when you have your 18s. Sometimes it's good to get a visual first. Okay, so here is my wheel with 18s. So if I carry this over, it certainly looks like 3/18 is equal to the 1/6 that we have there. And then I'm going to highlight this one and move it here. And it looks like I am highlighting 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I have 8 of the 18s highlighted, which would match the 4 9s. Okay, so now that I've kind of set up the picture of what I want you to see, I'm going to go ahead and do the abstract math part. And again, the more you practice it, the better you're going to get. I'm going to write 2 1/6 plus 3 4 9. Now I write it vertically because I want you to know that adding fractions is just like adding whole numbers. I can add the 2 plus 3 right now and I can get 5. Now I need to add the fraction part, but I can't because they're not the same size pieces. But then, oh yeah, that's right. The least, come on, pen. The least common denominator is 18. So I know what I'm going to do is I'm going to convert the 1/6 to a fraction over 18 and the 4 9 to a fraction over 18. And now I'm going to show you one more other way of how we can look at this. If I multiply any number by 1, it's the same value. But what I'm going to do is inside of my 1, I'm going to write 3/3. Because here's what I want you to see. I'm trying to get 18 as a denominator, and when I multiply fractions, I multiply the denominators, I multiply the numerators separately. 6 times 3 is 18, 1 times 3 is 3. Hey, that matches what we got down here for our fractional part. So this 1/6 is the same thing as 3/18. Now I'm going to take the 4/9, and I'm going to multiply that by a giant 1. And I also want to have 18 as my denominator. So I need to multiply 9 by 2 to get 18. So I'm going to multiply by 2 over 2, which is the same thing as 1, and 4 times 2 is 8. So now what I'm telling you is that 4/9 is equal to 8/18, which is exactly what we counted. It's just not always practical to draw a picture. Now I've got the same denominator, so the denominator tells you the size. I have 18. The numerator counts how many. How many do I have if I add 3 plus 8? I have 11. So the answer to this is 5 and 11/18. It was yards of ribbon. Next. Now we've got an example. This is going to be example 2, and it is going to be a subtraction problem, which says Miss K has 3 3/4 cups of flour, and she gives 2 3/10 cups of her flour. The units are still cups to Miss Fairchild. How much flour is left over? When you see the words left over, it usually means that you're subtracting. So the idea is, again, if I just look at it as how I know to set up subtraction problems vertically, I look at this and I go, oh, I can subtract the 4 minus 2 right now. That's easy. She gave away 4. She started with 4 cups. She gave away 2. That means she has 2 whole cups left. Now here's the harder part. Now I've got to figure out the fractional part. So what I want to do is I want to find a common denominator with 4 and 10. Maybe I'll put this one in a factor ladder because I know I can find the least common multiple. When I have no more common factors, remember I make an L. I multiply. 2 times 2 is 4 times 5 is 20. Okay, that was easy. Now I just found out that the least common denominator is 20. So LCD equals 20, which means I'm going to take this fourth and I'm going to cut it into 20ths. And then I want you to see that these are tenths. So I'm trying to figure out what tenths is when I make it into 20ths. But first I'm going to highlight everything. So I'm going to highlight the 3/4. So here's my 3/4. There's 2/4 colored in. There's 3/4 colored in. And then I'm going to color in the 3/10 so that you can see what that looks like. And then the least common denominator is 20. So it turns out that if I take and I have a wheel that looks like it's been cut up into 20ths and I put it on top, I could count how many 20ths you see highlighted because that was the same thing as 3/4. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it looks like I have 15 highlighted. And then on this one, I'm going to pull this over. And now, how many 20ths do you think are highlighted here? It looks like 1, 2, 3, 4, 5, 6. Well, let's go and do the math that proves that those pictures make sense. So now, remember my least common denominator is 20. So what I want to do is I want to create an equivalent fraction that's over 20. What do I need to multiply 4 by to get 20? Hopefully you're good at your 4s. It's times 5. That means I also have to multiply the 3 times 5. 3 times 5 is 15. Hey, that's exactly what we counted there. Now I'm going to change the 3/10 into an equivalent fraction over 20. This one's a little bit easier, right? Because we multiply by 2. So then I multiply the numerator by 2, and I get 6/20, which is exactly what we counted. So now I've got 4 take away 2 is 2, and now I know the size pieces are going to be 20ths because my denominator stays the same. And now I have 15 minus 6, which is 9. So I get 2 and 9/20, and then I'm going to put in cups because that was my unit. My units, 2 and 9/20 of a cup is left. So this is OYO. I want you to try this problem on your own. go ahead and pause the video and I will show you how to complete this. All right, I'm going to write 3 and 9 11, subtract 2 and 2/3. Right now I can already see that 3 minus 2 is 1. I don't know if I want to do that yet. I want to make sure I don't have to regroup. And then I've got a numerator of 11 and 3. And if you know that 3 and 11 are both prime, I multiply those two together to get 33 as my least common denominator. That's my least common denominator. So what I need to do is I need to multiply. This time I'm going to do the giant 1, and I need to get 33. So 30/3? I guess that's how you'd say that? Yeah, that sounds right. 30/3. Okay, so now these also have to be 30/3. All right, so I'm going to create 1. If I multiply 11 times 3, I get 33, so I multiply by 3/3. And for this one, if I multiply 3 times 11, so I multiply by 11/11. I'm not touching the whole numbers, I'm just dealing with the fractions. 9 times 3 is 27, 2 times 11 is 22. Now, because the 27 is bigger than the 22, I don't have to do any regrouping. 3 minus 2 is 1. I have 30/3 on the bottom, and now the numerator counts how many? 27 minus 22 is 5/33, and it was pounds, and I'm going to abbreviate pounds. So there's my example, 1 and 5/33 of a pound. That's how much is left. So that's what you're doing in the homework today. You're adding and subtracting fractions with different denominators. And so let me just write out the steps of what you need to do. And so I'm going to insert a page before. Okay, here's your 3 steps. You first are finding the least common denominator. Then you need to rewrite fractions to have the same denominator. The last thing you do is you either add or subtract the numerators, right? The ones who count how many. And then I'm going to say the last step is just keep the denominator, right? We didn't, after we rewrote, you shouldn't have to do anything with the denominator. Keep the denominator and maybe simplify would be your last step. Okay, good luck.